In this problem, we have the opportunity to look at four loads acting on a bar. These are external loads. And we are asked to evaluate or calculate the internal force in the middle of this bar between B and C. So to get started, we can already see that external equilibrium has been completed for us. And we might also realize that it may not even be necessary to perform this external equilibrium because we don't necessarily need to solve this problem by knowing what force Fd is. Notice that we've been given Fa, Fb, and Fc, so external equilibrium would help us figure out what Fd is. Nonetheless, there's a technique that we can use where we use method of slices or method of sections to figure out what is happening between B and C without looking at the right side. Okay, so we can use what Jeff Hansen would call the cover-up method on this side and be opening the face so that we don't see this and we have A and B acting on a bar and we're looking at the internal loading. So this is what a diagram would look like. We have defined a positive x coordinate system coming out of this open face for which we have done the slice. So you can think of, I've put up my hand and I've covered up this region right here. Now, when we perform equilibrium, we say that the summation of the forces in the x direction will be equal to 0. And we go ahead and see that Fa is acting in the minus x direction. And then we follow suit with Fb and Fbc. We can then solve for Fbc and plug in Fa and Fb numerically and get the following answer. And for the sake of still getting comfortable with Python to solve these types of problems, we'll go ahead and create a new Colab notebook or script for us to be able to solve this problem numerically very quickly. So once again, we do import MP, or numpy as MP, and then we'll go ahead and we only need to solve for Fa, or we only need to insert Fa and Fb. So Fa was 87 newtons and Fb is 42 newtons. All right, so this may be a little bit overkill, but nonetheless, I think it's helpful to get a little, see, and Gemini AI already knows what I might be wanting. And I'm going to say F the BC is equal to FA minus FB. And I'll go ahead and print. Yes, it knows what I want, doesn't it? FBC is going to be equal to, and then we do the np.round, and we do FBC, one decimal place should be enough, and then we plug in the units there, newtons. Okay, and that's the answer. Thank you very much.